Hope you all are doing good. Welcome to my YouTube channel. So today we will discuss the concept of electronic configuration. So first definition, the distribution of electrons in the different orbital is known as electronic configuration. So the filling of the orbital in the atom is a hypothetical concept. So electronic configuration is a hypothetical thing which we have made for our convenience. So, atoms are built up by feeding electrons in the orbitals. So we feed electrons in the orbitals and we make up an atom. So for filling the electrons, we have some rules and we will learn those rules step by step. They are really simple. And if you don't know the concept of orbitals, refer to my previous video in this section. Okay, it will help you. Otherwise, you won't be able to get this video. Okay, let us start. So we have the rule number 1. So what it states, in the ground state of an atom, an electron enters the orbital of lowest energy first, and subsequent electrons are fed in the order of increasing energies. Okay, now what this rule is saying, basically this rule is stating that so electron enters the lowest energy orbital first. So lowest energy orbital first, and then they are fed in order of their increasing energies. So basically we have to draw the lowest energy first. Now how to know the energies of the orbitals? The sequence can be easily remembered by a schematic diagram, and I will draw that diagram for you. So just listen carefully how I draw the diagram. So just draw 1s, 2s, 3s, 4s, 5s, 6s, and so on. So start from here, 2p, 3p, 4p, 5p, 6p. Then from the third one, 3d, 4d, 5d, 6d. And then start from this f, 4f, 5f, and 6f, and so on. Now make an arrow like this. Like this. Okay. And so on. So this is the lowest. So move like this now in this direction. So this is the sequence of energy. If you see, so 1s has the lowest energy. 1s has the lowest energy, followed by 2s. Then which orbital? Then comes 2p. Then comes 3s. And then comes 3p. After 3p comes 4s. After 4s comes 3d. And after 3d comes 4p. And after 4p comes 5s. And so on. So the lowest energy level, which is 1s would be filled first, followed by 2s, then 2p, then 3s, 3p, 4s, 3d, 4p, 5s, and so on. Okay. So this is the energy sequence. Draw this diagram. So it is really easy. Replay the video and see how I have drawn it. Fine. So this is the first rule. Lowest energy level would be filled first, followed by increasing order of the energies. So this is the energy sequence, and move like this. Okay. Next, we have rule number 2. What the rule number 2 says, orbitals can accommodate maximum of 2 electrons, and these must have opposite spin. Okay. So this means an orbital can have 0, 1, or 2 electrons. Moreover, if an orbital has 2 electrons, they must be of opposite spin. Now let me draw p subshell. So how to draw a p subshell? P subshell looks like this. And these are orbitals. This is px, py, and pz. So these are small orbitals. So orbital number 1, orbital number 2, orbital number 3. So this orbital can accommodate a maximum of 2 electrons. So 1 electron and 2 electrons. And these electrons should be of opposite spin. You can't make like this. this would be wrong. Okay. So basically orbitals can accommodate maximum of 2 electrons and they must be of opposite spin. And what the maximum electron you can fill in an orbital? You can fill a maximum of 2 electrons in an orbital. So you can't fill like this. Three electrons are not possible. Just 2 electrons are possible in the orbital. Hope this is clear. Now let us move to the rule 3. So the rule 3 states that electron pairing will not take place in an orbital of same energy until each orbital is singly filled. Now what it means? Let us take the example of p orbital. So I'll suppose I have to fill 4 electrons. So how to fill 4 electrons? Now you know that orbital can accommodate a maximum of 2 electrons, correct? So I'll make 2 electrons. 1 and 2. No, this is wrong way. We don't do like this. So they are saying electron pairing will not take place in an orbital of same energy until each orbital is singly filled. So focus on this line. Each orbital is singly filled. We have to first singly fill the orbital like this. 1, 2, 3. Now each orbital is singly filled. Now the pairing will take place and that also of opposite spin. Okay, so like in the p subshell, according to this rule, each 3p orbital must get 1 electron of parallel spin before one of them is receiving the second electron. And also the spins should be same. Don't put like this, one up spin, other down spin and other up spin. No, for the spin should be same. Hope the rules are clear. Now let us move to the electronic configurations of the elements. So I'll write few electronic configurations and few you will write with me. Okay, let us start with the atomic number 1, that is of hydrogen. Correct? So hydrogen, atomic number is 1, Z equals to 1. So you know the energy sequence now. We discussed it. So first of all, 1s would be filled. So it would be 1s1. So you have to write the elevated numbers. So elevated number represent the number of electrons. So 1s1. So how to draw the structure? The structure would be like this. Okay, now let us try to write for nitrogen. Nitrogen, the atomic number is 7. So what would be the electronic configuration? First of all, 1s2. The 1s orbital, apply all the 3 rules. So 1s would be fully filled. Next, we have to move to the higher energy level, which would be 2s. So 2s also fully filled, 2s2, correct? And now we are left with 3 more electrons and we will put them in 2p3. So how it looks like this. Like this. 1s2, 2s2, 2p3. Hope this is clear. Okay, I'll tell you, I'll try to explain you in more detail. Like let us take the example of sodium. Sodium, the atomic number is 11. So see, in the case of sodium, so first of all, write all the orbitals like in the energy sequence. So you have 1s, then you have 2s, then you have 2p, then you have 3s, then you have 3p. So this is the energy sequence. So now first of all, we have to put 2 electrons in the s orbital. So I'll put 2 here, 1 and 2. Okay, now I will move to the higher energy, which is 2s. So again, I have sufficient, I have still 8 more electrons. So I'll put 2 here, 1 and 2. Next, I have to fill the p orbital. I still have 4 are already filled and still have 7 more. So let us try to fill the p orbital. So applying the rules, they are singly filled first. So filling them singly. Then they are pairing starts, so pairing them up. Okay. And last, just one more electron left. So like this. So what is the electronic configuration? 1s2, 2s2, 2p6, 3s1. Okay. Now your work is to write the electronic configuration of first 20 elements. First 20 elements, open the periodic table and write the electronic configuration of first 20 elements and send us on the email. We will check it and will revert back. Okay. Now let us move to the 3D orbitals. Transition metals are. So the very first transition metal we have is scandium. So the atom, okay. Before that, let us write the electronic configuration of, let me tell you one more thing. Suppose you know about the noble gases. So we have noble gases like helium, neon, argon, correct? So let us try to write the electronic configuration of argon. So atomic number is 18. Okay, pause the video and you write it. Okay, so the electronic configuration would be 1s2, 2s2, 2p6, 3s2, 3p6. So this is the electronic configuration of argon. So if I now say write the electronic configuration of calcium, the atomic number is 20. So how to write it? So again, you have to list all these elements, correct? Oh, sorry, all these orbitals. Then only you will be able to write for the calcium. So we have an easy way. What we do, we write like this. We write argon, square bracket, and then we start. So up to argon, 3p6 was filled. So what we have next? We have next 4s orbital. So 4s2. So argon represents 18 electrons are filled. 18 electrons are filled. And next orbital you have 4x. Okay. So the electronic configuration of calcium would be argon 4s2. So this is the easier way. Okay, so in the energy sequence, what orbital comes after 4s? If you remember, after 4s, 3d comes. 3d comes after 4s. Okay, now we have to write for the scandium. Scandium, the atomic number is 21. So I will write argon, which is up to 18. 18 are filled. Now how many are left? Just 3 are left. So it should be 4s2, 3d1. So you can't write like this, calcium 3d1. No, only noble gases are permitted to write. Okay. So it should be like this, correct? 4s2, 3d1. But, you know what happens? 4s is a very small orbit, subshell. So it is like this. And 3d is really big. 3d has 5 orbitals. So due to repulsions in the 4s was fully filled. So due to repulsions, the energy of 4s increases and it get more energized, like comparatively to 3d. So the electronic, so this is the wrong way. The right way to write the electronic configuration is argon 3d1 4s2. So listen really carefully. Fill the 4s orbital first, but while writing, write the 3d first, then the 4s. The 3d will come before 4s. Why? Because of the energy demands. Energies and repulsions in the 4s orbital increasing drastically, and it goes to the higher energy level in comparison to the d orbital. Okay, so fill the 4s orbital first, but while writing, write the 3d first. Hope this is clear. So let me try to write one more for you. Vanadium. Vanadium atomic number is 23. So argon, up to argon, 18 are filled. So how many more? 5 are left. So 3d3. Okay, 4s2. First of all, 2 in the 4s. 2 in the 4s, just 3 are left. So 3d3. Okay, so this is the electronic configuration of vanadium. Okay, now you do one thing, right? For the chromium, Z is equal to 24. Write it, and write for manganese, Z is equal to 25. Pause the video and write it. Okay, so what I feel what you should must have written is argon 3d4 4s2, and for the manganese argon 3d5 4s2. Correct? I hope this is what you have written. Okay, now again pause the video and write the electronic configuration for copper. For the copper, Z equals to 929, which is the atomic, Z represents the atomic number. And zinc, right, for the zinc, Z equals to 30. Pause the video and write it. So for the copper, it would be, what you must have written is 3d9 4s2, and for the zinc 3d10 4s2. Correct? But now remember one thing. For the copper one and for the chromium one, this is a wrong electronic configuration. The chromium and the copper are exception. So they don't have electronic configuration like this. For the chromium, the correct electronic configuration is argon, and then 3d5 4s1. So this is for the chromium. Like manganese, manganese is also 3d5 4s2. And copper has the electronic configuration of argon 3d10 4s1. And zinc has argon 3d10 4s2. Now why? Why this? So this is the actual electronic configuration. And the expected one was 3d4 4s2 for the chromium. This was expected one. Correct? So why this is so? Any idea? Okay. So this is attributed to the fact that half-filled and completely filled electronic configurations have lower energy and therefore extra stability. This basically so now the three, if you see for the chromium case, D is half filled. Draw the D structure. 1, 2, 3, 4, 5. And 4s is also half filled. Correct? And there is a known fact that half filled, and fully filled have lower energy. Lower energy, if energy is less, more stability. They have lower energy and thus more stability. Okay. Therefore, to acquire the increased stability, one of the 4s electron goes to the nearby 3d orbital. And for the case of copper, it is fully filled. D is fully filled. Okay. Now, why this extra energy? So why they are getting extra stability? So this extra stability of half-filled and completely filled electronic configuration is due to their symmetrical arrangement and large exchange energy. So there are two things. Symmetrical arrangement, there comes symmetry, and symmetry always decreases the energy. Symmetrical arrangement plus large exchange energy. Now, what is exchange energy? If you want to know about it, comment it. I will make a video on exchange energy also. Okay, hope this is clear. So now, time for the homework. So your homework is to write the electronic configuration of 1 to 30 elements write the electronic configuration of 1 to 30 elements, send it on this email. Okay, we will check it and revert back. And one more important information, our Wisdom Science Institute also provide tuitions. So if you want any tuition on any topic of chemistry, you just mail us. Okay, hope you enjoyed the video. If you enjoyed it, do share it and like it. Okay, then see you. Bye-bye.